Okay, so we are starting from the second part, that is creation, 1963 to 1980. Okay, so chapter 4, Achievers. It's in the page number 24 of the PDF. I started my work at NASA at the Langley Research Center, that is LRC, in Hampton, Virginia. This is primarily an R&D center for advanced aerospace technology. One of my most vivid memories of LRC is of a piece of sculpture depicting a charioteer driving two horses, one representing scientific research and the other technological development, metaphorically encapsulating the interconnection between research and development. From LRC, I went to the Goddard Space Flight Center, that is the GSFC, at Greenbelt, Maryland. The center develops and manages most of NASA's Earth orbiting science and application satellites. It operates NASA's tracking networks for all space missions. Towards the end of my visit, I went to the Wallops Flight Facility at Wallops Island in East Coast, Virginia. This place was the base for NASA's sounding rocket program. Here, I saw a painting prominently displayed in the reception lobby. It depicted a battle scene with a few rockets flying in the background. A painting with this theme should be the most commonplace thing at a flight facility, but the painting caught my eye because the soldiers on the side launching the rockets were not white but dark-skinned, with the racial features of people found in South Asia. One day, my curiosity got the better of me, drawing me towards the painting. It turned out to be Tipu Sultan's army fighting the British. The painting depicted a fact forgotten in Tipu's own country, but commemorated here on the other side of the planet. I was happy to see an Indian glorified by NASA as a hero of warfare rocketry. My impression of the American people can be summarized by a quotation from Benjamin Franklin. Those things that hurt instruct. I realized that people in this part of the world meet their problems head on. They attempt to get out of them rather than suffer them. My mother had once narrated an incident from the Holy Book. After God created man, he asked the angels to prostrate themselves before Adam. Everybody prostrated themselves except Iblis or Satan, who refused. Prostrated is means you have to bow, which we Muslims we do while praying. So that's the same action. Okay, so everybody prostrated themselves except Iblis or Satan, who refused. Why did you not prostrate yourself? Allah asked. Allah is the God. You created me of fire and him of clay. Does not that make me nobler than Adam? Satan contended. God said, be gone from paradise. This is no place for your contemptuous pride. Satan obeyed, but not before cursing Adam with the same fate. Soon, Adam followed suit by becoming a transgressor after eating the forbidden fruit. Allah said, go hence and may your descendants live a life of doubt and mistrust. What makes life in Indian organization difficult is the widespread prevalence of this very contemptuous pride. It stops us from listening to our juniors, subordinates, and people down the line. You cannot expect a person to deliver results if you humiliate him, nor can you expect him to be creative if you abuse him or despise him. The line between firmness and harshness, between strong leadership and bullying, between discipline and vindictiveness is very fine, but it has to be drawn. Unfortunately, the only line prominently drawn in our country today is between the heroes and the zeros. On one side are a few hundred heroes, keeping 950 million people down on the other side. This situation has to be changed. I think the situation is still going on in our country, and I don't think we can recover from that organization soon. I think, in my opinion, I think every profession or every organization you take, there is always that senior junior problems, always that despiseness, that contemptuous. Everything is still going on in our country, and he has written it very long ago. So it's very surprising that it's still going on in a country after even after developing so much. Okay, so as the process of confronting and solving problems often requires hard work and is painful, we have endless procrastination. Actually, problems can be the cutting edge that actually distinguish between success and failure. They draw out innate courage and wisdom. As soon as I returned from NASA, India's first rocket launch took place on 21st November 1963. It was a sounding rocket called Nike Apache made at NASA. The rocket was assembled in the church building I have referred to earlier. The only equipment available to transport the rocket was a truck and a manually operated hydraulic crane. The assembled rocket was to be shifted from the church building to the launch pad by truck. When the rocket was lifted by the crane and was about to be placed on the launcher, it started tilting, indicating a leak in the hydraulic system of the crane. As we were fast approaching the launch time, that is 6 p.m., any repairs to the crane had to be ruled out. Fortunately, the leak was not large, and we managed to lift the rocket manually using our collective muscle power and finally placing it on the launcher. In the maiden Nike Apache launch, I was in charge of rocket integration and safety. Two of my colleagues who played a very active and crucial role in this launch were D. Iswaras and R. Arvamudan. Ishwar Das and R. Arvamudan. Ishwar Das undertook the rocket assembly and arranged the launch. Arvamudan, whom we called Dan, was in charge of radar, telemetry, and ground support. The launch was smooth and problem-free. We obtained excellent flight data and returned with a sense of pride and accomplishment. When we were relaxing the next evening at the dinner table, we received news of the assassination of the President John F. Kennedy in Dallas, Texas. We were appalled. The Kennedy years were a significant era in America when young men were at the helm of affairs. I used to read with interest about Kennedy's moves in the missile crisis of late 1962. The Soviet Union built missile sites in Cuba from which it would have been possible to launch attacks on American cities. Kennedy imposed a blockade or a quarantine barring the introduction of any offensive missiles to Cuba. America also threatened to respond to any Soviet nuclear attack from Cuba on any country in the Western Hemisphere by retaliating against the USSR. After 14 days of intense drama, the crisis was resolved by the Soviet Premier Khrushchev ordering that the Cuban bases be dismantled and the missiles returned to Russia. The next day, Professor Sarabhai had a detailed discussion with us on future plans. He was creating a new frontier in the field of science and technology in India. A new generation, scientists and engineers in the 30s and early 40s, was being charged with an unprecedented dynamism. Our biggest qualifications at INCOSPAR were not our degrees and training, but Professor Sarabhai's faith in your capabilities. After the successful launch of Nike Apache, he chose to share with us his dream of an Indian satellite launch vehicle. Professor Sarabhai's optimism was highly contagious. The very news of his coming to Tumba would electrify people and all laboratories, workshops, and design offices would hum with uneasing activity. People would work virtually round the clock because of the enthusiasm to show Professor Sarabhai something new, something that had not been done before in her country, be it a new design or a new method of fabrication or even an out of the way administrative procedure. Professor Sarabhai would often assign multiple tasks to a single person or a group. Though some of those tasks would appear totally unrelated in the beginning, they would at a later stage emerge as deeply interconnected. When Professor Sarabhai was talking to us about the satellite launch vehicle, he asked me, almost in the same breath, to take up studies on a rocket assisted takeoff system, that is RATO, for military aircraft. The two things that the two things had no apparent connection except in the mind of this great visionary. I knew that all I had to do was to remain alert and focused on my purpose. And sooner or later, an opportunity to do a challenging job would enter my laboratory. Professor Sarbai was ever willing to try out novel approaches and liked to draw in young people. He had the wisdom and judgment which enabled him to realize not only if something was well done, but also when it was time to stop. In my opinion, he was an ideal experimenter and innovator. When there were alternative courses of action for us, whose outcome was difficult to predict or to reconcile varying perspectives, Professor Sarabhai would resort to experimentation to resolve the issue. This was precisely the situation at Incospar in 1963. A bunch of young, inexperienced, but nevertheless energetic and enthusiastic persons were given the task of fleshing out the spirit of self reliance in the field of science and technology in general, and of space research in particular. It was the great example of leadership by trust. The rocket launch site later blossomed into the Tumba Equatorial Rocket Launch Station, that is TERLS. TERLS was established through active collaboration with France, USA, and USSR. The leader of the Indian space program, Professor Vikram Sarabhai, had comprehended the full implications of the challenge and had not balked at taking it on. So, balked means any hesitation. Right from the day INCOSPA was formed, he was aware of the need to organize an integrated national space program with the equipment for the manufacture of rockets and launch facilities developed and produced indigenously. With this in view, a wide-ranging program for scientific and technological development in rocket fuels, propulsion systems, aeronautics, aerospace materials, advanced fabrication techniques, rocket motor instrumentation, control and guidance systems, telemetry, tracking systems, and scientific instruments for experimentation in space were launched at the Space Science and Technology Center and the Physical Research Laboratory at Ahmedabad. Incidentally, this laboratory has produced a large number of Indian space scientists of extremely high caliber over the years. The real journey of the Indian aerospace program, however, had begun with the Rohini sounding rocket, that is RSR program. What is it that distinguishes a sounding rocket from a satellite launch vehicle, that is an SLV, and from a missile? In fact, there are three different kinds of rockets. Sounding rockets are normally used for probing the near Earth environment, including the upper regions of the atmosphere. While they can carry a variety of scientific payloads to a range of altitudes, they cannot impart the final velocity needed to orbit the payload. On the other hand, a launch vehicle is designed to inject into orbit a technological payload or satellite. The final stage of a launch vehicle provides the necessary velocity for a satellite to enter an orbit. This is a complex operation requiring onboard guidance and control systems. A missile, though belonging to the same family, is a still more complex system. In addition to the large terminal velocity and onboard guidance and control, it must have the capability to home on targets. When the targets are fast moving and capable of maneuvering, a missile is also required to carry out target tracking functions. The RSR program was responsible for the development and fabrication of sounding rockets and the associated onboard systems for scientific investigation in India. Under this program, a family of operational sounding rockets were developed. These rockets had wide-ranging capabilities, and to date, several hundreds of these rockets have been launched for various scientific and technological studies. I still remember that the first Rohini rocket consisted of a single solid propulsion motor weighing a mere 32 kg. It lifted a nominal 7 kg payload to an altitude of about 10 km. It was soon followed by another, to which one more solid propellant stage was added to dispatch multi-experiment payloads weighing nearly 100 kg to an altitude of over 350 km. The development of these rockets had resulted in a fully indigenous capability in the production of sounding rockets as well as their propellants. This program had brought into the country technology for the production of a very high performance solid propellants like those based on polyurethane and polybutane polymer. It later resulted in the setting up of a propellant fuel complex, that is a PFC, to manufacture strategic chemicals required for rocket engines, and a rocket propellant plant, RPP, to produce propellants. The development of Indian rockets in the 20th century can be seen as a revival of the 18th century dream of Tipu Sultan. When Tipu Sultan was killed, the British captured more than 700 rockets and subsystems of 900 rockets in the Battle of Thurukanahalli in 1799. His army had 27 brigades called Kushuns, and each brigade had a company of rocketmen called Jorgs. These rockets had been taken to England by William Congreve and were subjected by the British to what we call reverse engineering today. They were, of course, no GATT, IPR Act, or patent regime. With the death of Tipu, Indian rocketry also met its demise, at least for 150 years. Meanwhile, rocket technology made great strides abroad. Konstantin Sholkovsky in Russia, 1903, Robert Goddard in USA, 1914, and Hermann Oberth in Germany, 1923, gave rocketry new dimensions. In Nazi Germany, Werner von Braun's group produced V-2 short-range ballistic missiles and showered fire on the Allied forces. After the war, both the USA and the USSR captured their share of German rocket technology and rocket engineers. With this booty, they started to run their deadly arms race with missiles and warheads. Rocketry was reborn in India thanks to the technological vision of Prime Minister Jawaharlal Nehru. Professor Sarabhai took the challenge of giving physical dimensions to this dream. Very many individuals with myopic vision questioned the relevance of space activities in a newly independent nation, which was finding it difficult to feed its population. But neither Prime Minister Nehru nor Professor Sarabhai had any ambiguity of purpose. Their vision was very clear. If Indians were to play a meaningful role in the community of nations, they must be second to none in the application of advanced technologies to their real life problems. They had no intention of using it merely as a means to display our might. So I think if anyone has any doubts or if anyone has to discuss about something, you can ask. Hello.
Hi.
Yes.
Yes, Ajay.
Good evening, ma'am.
Good evening.
Yeah, basically the story I was deeply I don't know. Now I clarity about that mission of Kalamji.
Okay.
I, I, mm, mm, I don't have any doubt, but story was nice for knowing that Kalamji's struggles and whatever that in his career doing I really glad to tell about reverse engineering for that invented by Kalamji for doing some work. No, yes, correct. It is correct. No? It is correct, ma'am.
Can you repeat it? I think your voice is a bit
Oh,
muffled. Yeah.
uh,
Yeah. Now it's clear. Okay.
yeah.
Yeah.
I really like that part of that in story is a reverse engineering by Kalamji was invented. No, some project of that. No?
Yes. Yes.
Yes, I really like that.
Okay.
And
Have you watched the movie Rocketry?
yes, that rocketry was Raghavan's.
Yeah, Madhavans. Yeah.
Madhavans.
Yeah. You can
Yeah,
most
I
of the movie you can relate that these
yes,
things to the movie.
yes. I got it that this lines and story as
Yeah.
connecting that movie is
Yeah.
yes,
The
he
Professor
struggles.
Sarabhai.
Yes.
Yeah.
Names particularly I didn't remember,
Yeah.
but storyline was where yeah, that no story was connecting this.
Yeah. That's
Correct, same,
right.
same.
I think if you are watch the movie, you can relate it to it more clearly.
Yes. Literally coming the story. What is the connection?
Yes.
I watched so much of long time.
Mm. Yeah.
Uh,
Thank you, Ajay.
nicely spoken. Or what I should say about means
Mm.
nicely. Uh, nicely story was telling nicely. I can say that now.
Thank you.
Means pronunciation and answer accent language of the lines and situation that I really like that.
Okay. Thank you, Ajay.
So,
Anyone else has to say something?
I think other members didn't join. I think. Ma'am, good evening, ma'am.
Yeah.
I would like to point out two things which really right from the beginning of the story I have been noticing. One thing is that Mr. Abul Kalam had all like there was no caste discrimination at that time. If you see, like Christians are also there, Muslims are there, Hindus are there, they're
Yes.
there.
Mm.
It's a very good mix. Like nowadays we have that, but at that time it wasn't there. And second,
Yes, ma'am.
very good thing that he has pointed out that India, like we have our great Upanishads, our Vedas, Shastras, so many things. Here you see, 150 years back, Tipu Sultan had that rocketry. He had all,
Yes.
took it away to England to do research on it. So we should be very proud of our rich culture and heritage. Like
Yes.
Yes.
the advanced countries did not have this, but we had it.
We had it.
Yes,
Yes.
yes, ma'am.
Unfortunately, it was not popularized, but definitely we were the forerunners of this technology also.
Yes, ma'am.
For sure. Very correct, ma'am. So shall I continue now?
Yes, Shimnaz,
Yes.
for another 10 minutes, and then you can have 10, no, 15 minutes, and then you can have another discussion and we
Okay,
can
sure.
close it. Yeah, thank you so much, Shimnaz.
Okay, sure.
Thank you, Ajay. Thank you, Taranjit.
And,
Thank you.
Okay, so we'll move on to chapter 5,
yes. Yes, ma'am.
Dreamers.
Okay.
Okay, during his frequent visits to Tumba, Professor Sarabhai would openly review the progress of work with the entire team. He never gave directions. Rather, through a free exchange of views, he led us forward into new terrain, which often revealed an unforeseen solution. Perhaps he was aware that though a particular goal might be clear to himself and he could give adequate directions for its accomplishment, his team members might have resisted working towards a goal that made no sense to them. He considered the collective understanding of the problem the main attribute of effective leadership. He once told me, "Look, my job is to make decisions, but it is equally important to see to it that these decisions are accepted by my team members." In fact, Professor Sarabhai took a series of decisions that were to become the life mission of many. We would make our own rockets, our own satellite launch vehicles, and our own satellites. And this would not be done one by one, but concurrently in a multi-dimensional fashion. In the development of payloads for the sounding rockets, instead of getting a certain payload and then engineering it to fit into the rocket, we discussed the matter threadbare with the payload scientist working in different organizations and at different locations. I may even say that the most significant achievement of the sounding rocket program was to establish and maintain nationwide mutual trust. Perhaps realizing that I preferred to persuade people to do as they were told rather than use my legitimate authority, Professor Sarabhai assigned me the task of providing interface support to payload scientists. Almost all physical laboratories in India were involved in the sounding rocket program, each having its own mission, its own objective, and its own payload. These payloads were required to be integrated to the rocket structure so as to ensure their proper functioning and endurance under flight conditions. We had X-ray payloads to look at stars, payloads fitted with radio frequency mass spectrometers to analyze the gas composition of the upper atmosphere, sodium payloads to find out wind conditions, its direction and velocity. We also had ionospheric payloads to explore different layers of the atmosphere. I not only had to interact with scientists from TIFR, National Physical Laboratory and Physical Research Laboratory, but also with payload scientists from the USA, USSR, France, Germany, and Japan. I often read Khalil Gibran and I always find his words full of wisdom. Bread baked without love is a bitter bread that feeds but half a man's hunger. So those who cannot work with their hearts achieve but a hollow, half-hearted success that breeds bitterness all around. I think this quote has to be in
Yes.
memory. It's a very good quote.
Yes. I really like.
Yeah. So if you're a writer who would secretly prefer to be a lawyer or doctor, your written words will feed but half the hunger of your readers. If you're a teacher who would rather be a businessman, your instructions will meet but half the need for knowledge of your students. If you're a scientist who hates science, your performance will satisfy but half the needs of your mission. The personal unhappiness and failure to achieve results that comes from being a round peg in a square hole is not by any means new. But there are exceptions to this, like Professor Oda and Sudhakar, who bring to their work a personal touch of magic based upon their individual character, personality, inner motives, and perhaps the dreams crystallized within their hearts. They become so emotionally involved with their work that any dilution of the success of their efforts fills them with grief. Professor Oda was an X-ray payload scientist from the Institute of Space and Aeronautical Sciences, ISAS, Japan. I remember him as a diminutive man with a towering personality and eyes that radiated intelligence. His dedication to his work was exemplary. He would bring X-ray payloads from ISAS, which along with X-ray payloads made by Professor U.R. Rao, would be engineered by my team to fit into the nose cone of the Rohini rocket. At an altitude of 150 km, the nose cone would be separated by explosion of pyros triggered by an electronic timer. With this, the X-ray sensors would be exposed to space for collecting the required information about the emissions from stars. Together, Professor Oda and Professor Rao were a unique blend of intellect and dedication, which one rarely sees. One day, when I was working on the integration for Professor Oda's payload with my timer devices, he insisted on using the timers he had brought from Japan. To me, they looked flimsy, but Professor Oda stuck to his stand that the Indian timers be replaced by the Japanese ones. I yielded to his suggestion and replaced the timers. The rocket took off elegantly and attained the intended altitude. But the telemetry signal reported mission failure on account of timer malfunction. Professor Oda was so upset that tears welled up in his eyes. I was stunned by the emotional intensity of Professor Oda's response. He had clearly put his heart and soul into his work. Sudhakar was my colleague in the payload preparation laboratory. As part of the pre-launch schedule, we were filling and remotely pressing the hazardous sodium and thermite mix. As usual, it was a hot and humid day at Tumba. After the sixth such operation, Sudhakar and I went into the payload room to confirm the proper filling of the mix. Suddenly, a drop of sweat from his forehead fell in onto the sodium, and before we knew what was happening, there was a violent explosion which shook the room. For a few paralyzed seconds, I did not know what to do. The fire was spreading, and water would not extinguish the sodium fire. Trapped in this inferno, Sudhakar, however, did not lose his presence of mind. He broke the glass window with his bare hands and literally threw me out to safety before jumping out himself. I touched Sudhakar's bleeding hands in gratitude. He was smiling through his pain. Sudhakar spent many weeks in the hospital, recuperating from the severe burns he had received. At TERS, I was involved with rocket preparation activities, payload assembly, testing and evaluation, besides building subsystems like payload, housing, and jettisonable nose cones.
Jettisonable means what now?
Jettisonable.
Jettisonable. Yes.
Okay.
In the rocket language, I think so.
Okay, it's saying, yeah, it's something which can be like, can be dropped from an aircraft.
Oh, okay.
Okay, yeah.
Yeah.
Nose cones, yeah. Okay. Working with the nose cones led me as a natural consequence into the field of composite materials. It is interesting to know that the bows found during archaeological excavations at different sites in the country reveal that Indians used composite bows made of wood, sinew, and horn as early as the 11th century, at least 500 years before such bows were made in medieval Europe. The versatility of composites in the sense that they possess very desirable structure, thermal, electrical, chemical, and mechanical properties fascinated me. I was so enthused with these man-made materials that I was in a hurry to know everything about them almost overnight. I used to read up everything available on related topics. I was particularly interested in the glass and carbon fiber reinforced plastic composites. An FRP, that is fiber reinforced plastic composite, is composed of an inorganic fiber woven into a matrix that encloses it and gives the component its bulk form. In February 1969, Prime Minister Indira Gandhi visited Tumba to dedicate tolls to the international space science community. On this occasion, she commissioned the country's first filament winding machine in our laboratory. This event brought my team, which included C.R. Satya, P.N. Subramanian, and E.M.N. Satya Narayana, great satisfaction. We made high-strength glass clothes laminates to build non-magnetic payload housings and flew them in two-stage sounding rockets. We also wound and test rocket motor casings of up to 360 millimeter diameter. Slowly but surely, two Indian rockets were born at Thumba. They were christened Rohini and Menaka after the two mythological dancers in the court of Indra, the king of the sky. The Indian payloads no longer needed to be launched by French rockets. Could this have been done but for the atmosphere of trust and commitment which Professor Sarabhai had created in Kuspa? He brought into use each person's knowledge and skill. He made every man feel directly involved in problem solving. By the very fact of the team members' participation, the solutions became genuine and earned the trust of the entire team, resulting in total commitment towards implementation. Professor Sarabhai was matter of fact and never tried to hide his disappointment. He used to talk with us in an honest and objective manner. Sometimes I found him making things look more positive than they actually were, and then charming us by his almost magical powers of persuasion. When we were at the drawing board, he would bring someone from the developed world for a technical collaboration. That was a subtle way of challenging each one of us to stretch our capabilities. At the same time, even if we failed to meet certain objectives, he would praise whatever we had accomplished. Whenever he found any one of us going over his head and attempting a task for which he did not have the capability or skill, Professor Sarabhai would reassign activity in such a way so as to lower pressure and permit better quality of work to be performed. By the time the first Rohini 75 rocket was launched from Turles on 20th November 1967, almost each one of us was in his own group. Early next year, Professor Sarabhai wanted to see me urgently in Delhi. By now, I was accustomed to Professor Sarabhai's working methods. He was always full of enthusiasm and optimism. In such a great state of mind, sudden flashes of inspiration were almost natural. On reaching Delhi, I contacted Professor Sarabhai's secretary for an appointment and was asked to meet him at 3:30 a.m. at Hotel Asoka. Delhi, being a slightly unfamiliar place with an unfriendly climate for someone like me, conditioned to the warm and humid climate of South India, I decided to wait in the hotel lounge after finishing my dinner. I have always been a religious person in the sense that I maintain a working partnership with God. I was aware that the best work required more ability than I possessed, and therefore I needed help that only God could give me. I made a true estimate of my own ability, then raised it by 50% and put myself in God's hands. In this partnership, I have always received all the power I needed, and in fact have actually felt it flowing through me. Today, I can affirm that the kingdom of God is within you in the form of this power to help achieve your goals and realize your dreams. There are many different types and levels of experience that turn this internal power reaction critical. Sometimes, when we are ready, the gentlest of contacts with Him fills us with insight and wisdom. This could come from an encounter with another person, from a word, a question, a gesture, or even a look. Many a time, it could even through a book, a conversation, some phrase, even a line from a poem, or the mere sight of a picture. Without the slightest warning, something new breaks into your life and a secret decision is taken. A decision that you may be completely unconscious of to start with. I looked around the elegant lounge. Somebody had left a book on a nearby sofa. As if to fill the small hours of that cold night with some warm thoughts, I picked up the book and started browsing. I must have turned only a few pages of the book, but about which I do not remember a thing today. It was some popular book related to business management. I was not really reading it, only skimming over paragraphs and turning pages. Suddenly, my eyes fell on a passage in the book. It was a quotation from George Bernard Shaw. The gist of the quote was that All reasonable men adapt themselves to the world. Only a few unreasonable ones persist in trying to adapt the world to themselves. All progress in the world depends on these unreasonable men and their innovative and often non-conformist actions. I started reading the book from the Bernard Shaw passage onwards. The author was describing certain myths woven around the concept and the process of innovation in the industry and business. I read about the myth of strategic planning. It is generally believed that substantial strategic and technological planning greatly increases the odds of a no surprises outcome. The author was of the opinion that it is essential for a project manager to learn to live with uncertainty and ambiguity. He felt that it was a myth to hold that the key to economic success is computability. A quotation from General George Patton was given as a counterpoint to this myth that a good plan violently executed right now is far better than a perfect plan executed next week. It is a myth that to win big one must strive to optimize, the author felt. Optimization wins only on paper, but would invariably lose later in the real world, the book said. Waiting in the hotel lobby at 1 a.m. for an appointment 2 hours later was certainly not a reasonable proposition, neither for me nor for Professor Sarabhai. But then Professor Sarabhai had always exhibited a strong component of unorthodoxy in his character. He was running the show of space research in the country, understaffed, overworked, nevertheless in a successful manner. Suddenly, I became aware of another man who came and sat down on the sofa opposite mine. He was a well-built person with an intelligent look and refined posture. Unlike me, always disorderly in my dress, this man was wearing elegant clothes. Notwithstanding the odd hours, he was alert and vivacious. There was a strange magnetism about him which derailed the train of my thoughts on innovation. And before I could get back to the book, I was informed that Professor Sarabhai was ready to receive me. I left the book on the nearby sofa from where I had picked it up. I was surprised when the man sitting on the opposite sofa was also asked to come inside. Who was he? It was not long before my question was answered. Even before we sat down, Professor Sarabhai introduced us to each other. He was Group Captain V.S. Narayanan from Air Headquarters. Professor Sarabhai ordered coffee for both of us and unfolded his plan of developing a rocket-assisted takeoff system, RATO, for military aircraft. This would help our warplanes to take off from short runways in the Himalayas. Hot coffee was served over small talk. It was totally uncharacteristic of Professor Sarabhai. But as soon as we finished the coffee, Professor Sarabhai rose and asked us to accompany him to Tilpat Range on the outskirts of Delhi. As we were passing through the lobby, I threw a cursory glance at the sofa where I had left the book. It was not there. It was about an hour's drive to the range. Professor Sarabhai showed us a Russian RATO. If I get you the motors of this system from Russia, could you do it in 18 months' time? Professor Sarabhai asked us. Yes, we can. Both GP Captain V.S. Narayanan and I spoke almost simultaneously. Professor Sarabhai's face beamed, reflecting our fascination. I recalled that I had read, "He will bestow on you a light to walk in." After dropping us back at the Hotel Ashoka, Professor Sarabhai went to the Prime Minister's house for a breakfast meeting. By that evening, the news of India taking up the indigenous development of a device to help short-run takeoffs by high-performance military aircraft with myself heading the project was made public. I was filled with many emotions, happiness, gratitude, a sense of fulfillment, and these lines from a little-known poet of the 19th century crossed my mind. For all your days prepare and meet them ever alike. When you are the anvil, bear. When you are the hammer, strike.
Shimnaz,
Okay.
you can stop and you
Okay.
can start off the discussion.
Yeah, sure.
Yeah.
Okay. So,
It is wonderful achievement for that man, for that achieving that rocket from India. in that time, every.
Ajay, can you come near to the mic?
Oh, okay, sorry.
I can't hear you.
Am I audible?
Yeah, okay. Yeah.
It is a
Yeah,
it
sure.
is a wonderful achievement for Indians in that time, in such activities by rocket inventions and going to that successful or unsuccessful. In the last moment, there was rocket what hot. What is that name of rocket? Air. In that last paragraph, did you say, ma'am? That one filled with emotions. That all. It was very much nice.
Okay.
It's okay to tell that, ma'am. I am telling like what I know. What that one that was I'm saying.
If you know anything, you can speak up. No worries.
Yes, ma'am. Thank you.
Yeah.
Anything I have to say, ma'am? I think
No,
is
that's all, Ajay. It's okay. Taranjit, you have to say anything, and Vignesh? If you both speak, we can close the meeting.
Majorly, this piece has technical specifications, but that George Bernard Shaw piece was really worth reading. That things that
Yes.
yes, things that have to
Yes.
take place, and especially people whom we call stupid or we think that their ideas are not good. They are the ones who make inventions in this world.
Yes.
yes.
Edison, all those very like real good examples for them.
Yes.
Yes.
I think so. It's true. Good night, everyone. I think so. Time up.
Vignesh, would you like to say anything?
Ma'am, I joined very late, ma'am.
Okay.
Okay, fine. Okay, please join on time. You'll enjoy the book. The book is amazing. It's opening all our eyes to what beauty of our own culture and our own this thing is. So please do come on time. Okay,
Yes, ma'am. Yes, ma'am. I will
it's an
next time.
eye-opening book. Yeah.
And I can have suggestions also. Like, do you want me to change anything in the reading or
No.
anything? I would
This
like to take this.
it is very nice, lovable to listen that voice like reading.
Okay, thank you so much.
Story.
I would like to take any suggestions if you want. Like, I'm ready.
No, it is correct.
The voice is very soothing, Shamnaz. Very nice, reading very well at a very good pace.
Yes.
Okay, so thank you so much.
Thank you so much.
Thank you, Shamnaz. Good night,
Thank-
everyone.
Thank
Thank you
you.
for valuable time, ma'am.
Yeah,
Everybody.
thank you. You all, thank you.
Thank you.